Hello, good morning, everyone. Welcome to today's keynote and second day of Tech Community Day. Cool, you guys are coming back from the welcome words from the team. I am so happy and very honored to be today here with Steve Jones. For those that are not familiar with him, probably you are, but he's the man behind SQL Server Central and that awesome website that has a ton of content related to SQL Server, many other databases and technologies. Right, Steve?
A little bit, mostly SQL Server, but a little bit here and there for Linux and Postgres and other things as well.
All right. And today's keynote title is The Future of Database Development, a very interesting topic. And who better than Steve to tell us what's going, what will be the future for us as DBAs or maybe database developers as a developer. I have a quick intro slides here. First of all, these are the communities behind this event: the SQL Server User Group from Guatemala, the Microsoft Dev Group Coban, the Docker Guatemala, and Kubernetes Guatemala. These are the communities that are behind this awesome event. It's for free, so enjoy it. And please join us. We have a few social networks accounts, or you can find us on Facebook, Twitter, on YouTube. Subscribe to the channel so you will have access to all the playlists from yesterday and what is going to be prepared for you guys today. Here's a QR code if you want to scan it. And as always, we have technical assistance. If you have any questions, please feel free to drop a comment on the YouTube comment section, or you can join us at Slack and post any comment there. Steve, are you going to be hanging around on Slack for a short period of time after your session?
I will. I'll be happy to take questions and discuss things with people.
Okay, that would be great. So there you have it. Steve will be hanging around with us. If you have any question, anything you would like to, follow up with him after his session, that would be a great opportunity for you guys to interact with him. And I think that's it. And without further ado, I will turn over to you, Steve.
Thank you, Carlos. Well, thank you very much for having me, and welcome everybody. Thank you for coming to Tech Community Day 2020. It's the second day today. Welcome to everybody in Guatemala. I'm sorry that I couldn't come down to Guatemala in person, but perhaps some point in the future. So if you attended any of the sessions yesterday, there were some fantastic things. I watched a few. I think there's probably some things that you could learn. And, today we're doing it again. If today's your first day, welcome to the day of learning. I hope you get some knowledge, some inspiration, some excitement about working with software and data. There is a question panel in the Slack, and then there's one on YouTube. I'll take those at the end, or I'll stay later to answer them if you want. But what I want to do is kind of talk in this keynote about where I think the future of database development is going to move in the future, not necessarily this year, next year, but a little bit longer term. I am a relational database person for most of my career. That's where I've primarily worked. But I think that all of these data stores, all the places that we use to store the data that we use with software, are going to move in this direction over time. Now, this is more for development, not production. Certainly, I think some of these concepts may flow into production, and we do need to get data from production back to development. But this is where I think the kind of the DevOps database development area will move, and the high performers, the elite performers, are going to move in this direction sooner rather than later. So in most of my career, as I built software, it was more complex. And I think over time, it's gotten simpler. Now, when I started off in building software, often I would get a project or I would join a new team, and somebody would give me a list of instructions that was in an email, or maybe there was a README of some sort. Then I had to go install software. I had to go find files and installers and dependencies. I might have to change configuration settings in different files. And really, I've dealt with pages and pages of setup instructions in Word or Google Docs, or really for me at my age, it was WordPerfect, where I saw many documents. Even today, I still see developers sometimes taking hours or days to get set up on a new project, or certainly when they start with a new company, trying to work through all the instructions and get all the things set up. Now, those instructions are never up to date. They never have every single step that needs to be followed because the world of software changes rapidly. and we often have to adapt and we forget to update documentation. There's a couple books on the screen. In the Unicorn Project, which is the second book, there's a character in there, Maxine. And in the book, it's amusing to me that she struggles to get a system set up to actually just compile her software and build the project. It takes her days and days and days. And it's not completely uncommon, though I have seen things get much better. Both of these books are about software development and a little bit of a satire and how it used to be, or maybe how it is for you today, for some of you. But it shows that there are better ways to build software. And a lot of that is the DevOps movement, which gives us kind of an overreaching framework for things we want to achieve, but we still have to work through how to implement all those things. So I work for Redgate Software, and I deal with a lot of different customers and clients. And one of the things that I found is that modern software development has gotten easier for many people. I don't know if it's most, I don't know how many we'd say there, but certainly I see a lot of advances in software to make it easier to set up a machine and run a software project. I think Microsoft has helped, but plenty of other environments have as well. So we've often gotten better version control in systems. Early in my career, I think it was like 20% of organizations use version control. Now I think it's up into the 60, 70, 80% range, which still feels low to me. But Git has really become a very common way of hosting code, both for individuals and organizations. And then the various online repositories like GitHub or Bitbucket or Azure DevOps have made it really easy for us to share software, both within a company and just in the community as well. Companies have adopted package managers. So for not so much database people, but for software developers using NPM or Yarn or apt-get or some other package manager has really made it smooth and easy to install software in your machine. As a matter of fact, in the Microsoft world, in the Windows world, if you haven't tried Chocolatey, you should go to Chocolatey and look at how that actually works, because it's an amazing package management facility for keeping software updated. The last 5 years or so, DevOps has been an incredible force in the world of software, and it's changed the way that we think about building, testing, and distributing software amongst different machines. I think the idea of DevOps is something that all of us should be adopting, though we will actually implement it in our own way, because it really does make it easier for us to build software and then have confidence that will work well. And then the last part of a thing that I think is starting to take the world by storm is containers. Many of you have probably heard of containers. There were a number of sessions yesterday, I think some today, on containers as well, and Kubernetes. And this idea of having a way to package my software and guarantee it will run somewhere is the phenomenal way of building software and distributing it. I've been talking to people and working with them that have built containers for about 10 years now. And while I don't run into a lot of customers actually doing this in their development areas, I do think it is going to become more and more common over time for a number of the reasons that were in the keynote yesterday from Nigel Poulton. So I want to show you something here. I've got this animation where I just wanted to see how easy is it to set up a random software project. I tend to deal with databases, but I do have software to deal with at times, and I'm always trying to learn. So I Googled for some random ASP.NET project, and I found this eShop on Web repository, which was somebody put up for their book. They built this reference application. And so I wanted to see how does it take to install this? Well, I ran git clone on the repository from GitHub, where I just copied down all the code to my machine. So I had all of that source code available in a directory. I didn't have to install anything there. All I did was run 2 Docker instructions here. So I ran the Docker compose build and the Docker compose up to get the application running. And inside of a few minutes, I had a web application running with a database backend that I could play with, that I could test. I could stop this and change the source code and then restart it. And if you watch this animation, most of the time here is actually the slow download of the Git repository. It's, for some reason, I had this pause in my internet while it was running, but this was less than 5 minutes of my time to get an ASP.NET application running. I didn't have to configure SQL Server. There was no instructions for security to set up. I didn't have to configure IIS. Didn't have to find any dependencies. This containerized application, which I just searched on Google and downloaded, inside of 5 minutes was running on my system. And I don't see everybody doing this, but I see more and more projects being started like this, where somebody downloads a repository and they run the application in Visual Studio, or they run it in Eclipse, or they can run it as a container, and they just can get started. And so instead of this taking days or weeks or hours, it happens very, very quickly. Now, certainly there's a minor amount of infrastructure that I had to install Docker. I had to make sure that my Windows machine was up to date. I had to have Git running, but that's pretty minimal compared to the process of most database development. Here I'm up and running in minutes. This works great for the application, but for the database, it's a little more challenging, because for most applications, we require a database platform that we can run. So I need somewhere to run it. Certainly I can use my laptop or a VM, or maybe I need a cloud server, or I need to request space on some machine in my organization. Then I have to install the database platform itself, or somebody has to, and live with the ongoing administration, maintenance, patching, et cetera, that we deal with when we run a piece of software. Now, storage is always an issue. Where do I store things? Do I have to allocate extra drives or request LUNs or whatever mechanism I need? And then, of course, when I get an application up and running, or I get a database created, what about the data that's inside of there? How do I get that set up for my application? Sometimes I might have it. Somebody maybe give me a backup. Maybe I recreate my own data. It's a challenge to work with data. And I think data is maybe the biggest challenge for many, many developers. Then there are the issues of, as I develop my application, as I test out new features and functions, I may delete data. I may change data. How do I reset that? How do I ensure that I can retest things in a repeatable manner, which is what we want to do? This is especially challenging for people that are building software that imports data. If I import all this data and I realize there's an issue, or I want to change my process, how do I get rid of the data and reset it? Do I drop the database? Do I truncate tables? What do I do? What if I'm testing merges? These are very challenging problems for many software developers, and they create a lot of friction. And then maybe the last part, I think, is the most important as we try to build teams and have a more rapid development where we can test small features. How do I branch my database? Now, with an application, I can branch in Git, and I get a new copy of the code, and I can change some things. And if I want to know what it used to look like, I can switch to the other branch. But how do I do that with the database? If I've added a table in a database, or I've deleted a table or changed something, and I want to switch branches with my code, what do I do with the database? Now, to be fair, there are solutions for all these things. We certainly deal with all these problems today, but they're not very smooth and easy. They cause a lot of inefficiency and friction in how we work in teams. As a matter of fact, if I look at the eShop web instructions, and this is the Git repo that I actually found, you'll notice that the Docker instructions are very simple. There's two things I need to run, but it does give me the ability to configure SQL Server. And you'll notice I've got to find a file. I need to go to SQL Server, make sure I have credentials so that I can set up connection strings. I then need to change some of the code to make sure that it works correctly, it's pointing in the right place, edit some files, a lot of instructions. And what happens if I go through all of this and I have a problem? What happens if I think I've followed all these instructions and it still doesn't work? Well, I might get really frustrated, annoyed, or I might go interrupt other people and complain to them, why doesn't this work? And seek assistance from somebody else, which is fine, except that it feels like an unnecessary step. Why is it so hard to actually get a database set up and working with an application? Now, I've never seen anybody destroy a computer for this reason, but I certainly have seen developers get frustrated and smash keyboards on a desk or throw them in a wall. And it's a very upsetting process that I think permeates database development. So often I find developers want to move to some other type of data store. They want to move JSON flat files, or they want to try some new NoSQL database, which isn't necessarily going to solve the problem that my development process isn't smooth to get up and running, and it isn't smooth to continue with over time. So I think we can actually do better. And I think that containers are a big part of this in the future. As I said, I don't run into a lot of customers now that are using containers. I find a tremendous amount of interest in people wanting to get started, but they're often struggling and trying to decide, how do I implement this and make it go? Now, I don't want to dive too deeply into what containers are and any of the other technologies, but essentially it does give me a way to create this immutable image which is how my application should look. And then I can package that up and create an instance of it in container that runs the same anywhere. Now, there's kernel issues, right? I mean, I need Linux kernels for Linux containers and Windows kernels for Windows containers. But essentially, I have that ability to ensure that when the container runs on my machine as a developer, it will run in the same way on a CI machine or a QA machine. It will run the same way in a production machine, whether that's in my data center or if that's in the Azure cloud or AWS cloud or Google cloud or anyone else. And it's really phenomenal to embrace this concept and see how this works. Now, I said they're immutable, which is a very important concept in computer science. Essentially means I can't reversion it. I can't change that. I certainly can change data, the application works, but I can't change the version of my software. If I need to upgrade this, if I need to patch it, I create a new container and I have a new version of the software. If I find a problem with that and I need to go backwards, I use the old container. So it's phenomenal to use containers in understanding the flexibility and advantages I get. A SQL Server runs in containers starting with 2017. Many of the other data stores run in containers now. So whether you need Redis or Elasticsearch or Oracle or Postgres, you can get a container to run these. And maybe more importantly, you can package those with your application for database development. And I want to give you a view into how I think this will go. So I've got another animation here. And the first thing you should notice is there's no SQL Server services running. I've done this demo before and showed people we'll actually shut down the services. And in this case, there's actually a Postgres database as well. And I don't have the Postgres service running either. So to get this set up, I only had to do a couple of steps. So I had Git, of course, and then I had Docker running. I actually downloaded this Spawn thing as well, which is just a service application that allows me to connect to a database. And so really, I ran those 3 software installs, which were very simple, authenticated to the service, and then downloaded a Git repository, and then ran Yarn. Now, Yarn is a package manager that just handles any software dependencies. So any of the dependencies I need for this application, which is a .NET, I don't think it's core, I think it's just .NET standard with React front end, I could just run Yarn to have that work. And then what happens from there is I just start up the application. I just start the Yarn application, and it starts running my repository. Now, as we go through this and you look at this, it does a number of things, and then it starts up an application. And in this case, the application is another web app that just starts running. But this web application has data because I can log into it and I can see certain things that are stored in the various databases. So my login here is stored in the SQL Server database, and then the data elements on the screen here for my list are stored in a Postgres database. But essentially, with running 3 or 4 commands, I've built this application and I have it up and running. Now, when this starts up again, I want to point out a couple of things that I think are very interesting in how this works. The first one is that the application, when it starts, is looking for containers. In this case, I don't have the containers running. So it sees the images and it starts to create the containers based on those images. And you can see that it starts up these databases relatively quickly. So it checks if the containers exist, and then it starts to create them. And inside of a few seconds, I have these containers up and running. Once they're up and running, I actually start to upgrade them because don't forget, this is database development. So what's in the container that I have there may not be as current as the code that's actually in my repository. And so you'll see it actually starts to use Flyway to run migrations or SQL scripts to upgrade the database to the latest version of code that I need as a developer. So in this case, somebody had created a table, somebody had created a stored procedure that wasn't in the container. When I downloaded it, it gets applied to the database. So each time I start, I'm at the latest version of the database in this branch of source code. I don't have to do anything special. It's just automatically applied. Once both containers or both databases are upgraded, what happens is the application starts as a normal application and I can just log in and start using it. If I need to stop it and change something, I can do that, and my containers will still exist. I have the ability to get rid of a container. So if I wanted to actually reset my application to a starting point, because I'm testing something as a software developer, I can delete those containers. And then when I restart the application, it'll create new containers from that known foundation, that known starting point. It'll run the upgrades for any SQL statements that need to be run. And then my application will work again. So I have the ability to do this. If I switch branches, I get a new set of containers. Just like it starts up here, if I were to switch a branch, I would actually get a new set of containers that would start back at that base. And I could then use those to test something. If I need to switch back to the old branch because I'm comparing how the application might work in a before-after scenario where I'm looking at where most developers work, and then I have my own copy of the code into my branch, I can do that. And I can start and stop without having any of the struggles and infrastructure hassles of restoring a database or manually changing data or any other challenges that I find developers dealing with all the time. Now, at the very end of this, I pop over to the website where it says, this is the Spawn project. At Redgate, we started a research project years ago on how we could do better DevOps database development. And, I remember sitting down with this group of developers and talking about how we do database development, what are the challenges. And I wasn't sure if they'd find any better way to do it. But after about a year and a half, they came up with the Spawn project. And I was amazed how creative they were in solving this problem by providing databases as a service. And that's what this really is that there's a database as a service here. So I don't mean to imply that we should be using this from Redgate or the cloud vendors or anywhere else, but more that however I'm going to do database development, the future is going to require the database to just be a service that I say, I need something new, of this shape, size, color, and it will just get created for me. And I don't have to manage it, and I don't have to worry about it. I think it will happen with containers because it becomes very quick and easy to start up containers and start up copies of containers. And that's one of the big points of the future of database development is that every developer, every CI process, every QA server should all start from the same version of the database so that we know that we're building and testing the correct thing. Ultimately, that's probably built off of production somehow, but I want to ensure that everybody has a known foundation that with which they start and they make their changes. And then as we accept those changes, as we think that they're ready to push forward, we ensure that those changes get distributed to all the other developers. And we don't want to have to worry about virtual machines and servers or anything else. We need programmatic access to our databases, which is where the service comes from, which is why it becomes important that these images are automatically built, that they're available to be accessed programmatically, and that they're automatically upgraded as we push code through our system. So they're always around. And maybe more importantly, that we're sharing the same set of data, the same state of data that everybody needs when they're starting to build development. Now, to be fair, there are solutions to do this stuff now, but I've never seen it done very smoothly. And usually these are bespoke or custom solutions for a particular organization or really a particular project. The container lifecycle just integrates into the flow of DevOps like we would do anywhere else. So starting over here on the left, when the application starts up and calls the service, it creates a container. That container runs and developers use it. They write code. As they write code, they commit that code with their database code and their application code. Now, it's not really relevant whether this is one repository or multiple repositories or different teams, but all that code gets committed. We implement a CI process that automatically validates this code. It would use the same image that the developer used, but it would validate that any changes are valid changes, they adhere to standards, they pass our tests, all the things that we do with both application and database software. And once that we're sure that we pass all of those processes, we produce a new image. So we extend our CI process to not just do the validation, but also to produce a new image. We upload that image to a repository of some sort, so it goes to developers. Next time the developers start, they automatically get the new image, or perhaps they have the choice of having two images in rotation. They'll pull the new version of the code down. Once they restart the app, it calls the service, and then we repeat this process over and over and over again. Now, trying to do this with containers is a great way to do it, but it's not super simple. If you've worked with containers, you might realize that beyond about 4 or 5 containers, managing them becomes a challenge. So I do think that ultimately Kubernetes is going to be the way that we do this. And I use Kubernetes as a generic here, not necessarily the Kubernetes project per se, but some orchestration engine. And orchestration really just means it's a management layer. If you want to know more about it, Nigel Poulton had a nice keynote yesterday where he talked about Kubernetes, and he's a big Kubernetes proponent. But essentially, in this case, each of those pods is a set of containers. In this case, they're running the Couchbase database store. And Kubernetes is just managing the execution and distribution of all of these different containers across different machines. Typically virtual machines, but they could be in the cloud. They could be local. It doesn't really matter. The point is that this Kubernetes service will run the same on my data center, or really even on my laptop, as it will run in Azure Cloud or AWS Cloud or anywhere else. So I have the ability to deploy and distribute my development to wherever it's appropriate for me. And then as we add developers, or as we add new QA servers or more intense processes, we just scale out our Kubernetes server, and it handles it across all the machines we need. We just add hardware. It handles the storage. It handles all of the various mechanisms that we need to run this. Ultimately, I think the future of database development is with containers and some orchestration engine. We'll use this not only for our software, but we'll use it for our data stores as well. We'll have programmatic access to allow us to connect those things together and deal with networking and naming and all the things we deal with. And then we'll use data virtualization to deal with the storage and data challenges. More and more vendors are working in different data virtualization areas. At Redgate, we have some solutions. Some other people have similar ones. There's different vendors. But there's this challenge with databases in the scale that we have of how do I take a database that's a gigabyte or 10 gigabytes or 100 gigabytes or a terabyte and scale that across multiple developers and multiple processes without just having to buy a ton of storage. Data virtualization really is going to be part of this future. And then I think the programmatic integration, so that I can create a database from a service, I'll get back credentials and addresses and all the things I need. And then I integrate those into my application so that I can very quickly and easily have the application up and running for my developers. Now, again, some of this could move forward to production, but this is really more about development. And then, of course, I'll just use some sort of cluster software like Kubernetes or Mesos or whatever, Docker Swarm. And I'll integrate this in my CI/CD process that ensures that as my developers build code, we're automatically upgrading things once we've decided this code needs to push forward. I really think this is going to happen, but as I said, not today. I really think this is probably in the next decade. And last year was the first time that I thought it was probably 10 years away. So maybe we're talking 8-9 years away now, where this will become common. So I think about this in terms of virtualization. When I started using VMware, it was 1999, and very few people did that. And in the early 2000s, most companies were hesitant to move things to virtual machines. Today, nobody thinks twice about using a virtual machine. And I think that's where we're going with containers and Kubernetes. That in 10 years, most of us won't think twice about using the container for our application software and for our data store. Slowly over time, this will happen. As I said, there are companies doing some of this now. I see it starting to happen in places, but it's not common. And I think 10 years is about the level where it needs to be common. And part of the 10 years is that I think starting with 2017, containers became possible in SQL Server. Really in 2019, now I start to see people actually using them. And so I think it's going to take about 10 years for most of us to upgrade the majority of our systems or to be comfortable with things running in SQL Server 2019 or later. And I think the same thing for Oracle and Postgres and other things, that we're starting to slowly get comfortable with the idea of running these in containers. There are challenges. I don't think this is simple and easy. Dealing with data volumes is a hassle, and it is a challenge that we certainly have to do. Data virtualization solutions for now are not free. They definitely require some sort of budget. So not only do we have to get the software, but we have to better understand how best to use it. We do need some sort of database as a service vendor solution coming. I don't know what this will take. I do know that right now, when I get a database from Amazon RDS or Aurora or from Azure, all I've gotten is a base database. I haven't really gotten anything that's useful to me as a developer. And so I think we need somebody that provides a service that makes it easy for me to request a database that looks like what I need in my application, or that's built from some image that I've already produced as part of my CI process. I certainly also think that we need a way to manage those images. So we need a container registry that works well for companies. I think it took quite a while for GitHub to be common in companies to say, I'm willing to upload code to a public place, or I'm willing to buy a private repository from a vendor and use them to manage our code. I think it's going to take a while for container images as well to get there. And I think we need to become comfortable with Kubernetes and how we configure it. I really don't think many of us will admin and run Kubernetes. I think that Kubernetes continues to improve constantly, but for most of us, we'll buy some sort of management service, whether that's Google Kubernetes service or Azure Kubernetes service, or it's something like Azure Stack where the Kubernetes service is running on premises, but it's being managed as part of kind of this cloud hosting thing or from this vendor. We need that to happen. And then the very last thing here is data subsetting. Now, I often find that vendors talk about the challenges of database development. They don't think about the challenges of data. And in almost every conversation I have with customers across the last 10 years, we talk about how do I produce a viable data set or a minimally viable data set for developers that is useful in working with their code. And often what we do is we default to a copy of production, which has security issues, and it certainly has volume issues. And often we end up having to share that amongst a team of developers, which means I have collisions when I write code. The idea of data subsetting and getting a small set of data that's representing to my problem is something that I haven't seen companies really tackle, even though customers always ask for it. And I think it's because we, in some sense, think it's easy for developers to create data, or we think it's easy for us to just pick 10 customers and test them. The problem is that we need to maintain that and make that work over time. And trying to go from a 1 terabyte database and cut down that data set to a 5 gigabyte data set is a real challenge in its product. And so I think that we need to find solutions for data subsetting. If you think that getting a copy of production that's 1/10 the size and is obviously anonymized or secured in some way, we've sanitized the data. If you think that's useful, I really urge you to contact different vendors and say, we would like to see a solution. Send something to sales@redgate.com, send it to any other vendor, because we need some innovation in this space, and we need people to come up with solutions that allow us to shrink a copy of our database down, but still make it usable for developers. So that's all I have today. As I said, I think the future of development, database development, is 10 years away, and it's going to involve containers. If you want to talk to me or get a hold of me, here's my contact information. I'll certainly be doing some more writing and discussing this on my blog and at SQL Server Central. But hopefully you've enjoyed this and you're looking forward to a great day here at Tech Community Day 2020. So Carlos, questions, things I should look at?
Yes, Steve. First of all, thank you very much for this great presentation. Lots of very thoughtful things that we have to keep in mind for next year's. Thank you so much. That was great.
My pleasure.
So yeah, we have many questions coming up. First of all, there is Alba from Honduras saying, morning, everyone. Greetings from Honduras. So the people from all over the world.
Yeah, thank you very much. Hopefully I'll get to tour down there at some point in time. Maybe Carlos and I will take a trip down Central and South America.
Yeah, of course. All right. So people was asking for more information about Spawn, and Alba help us put in the URL on the chat window. But what could you please provide us like a quick summary what Spawn is? People is very interested in this.
So every day we have a research arm that does certain work and research, and we investigate various things having to do with databases. And one of those was database development. And the Spawn project came out of that. It's really about how would we envision a database as a service? How would I get started with this? And so we've actually set this up, and we're actually starting to use this internally for certain projects. So it says beta, but we don't really want to support it and sell it right now. Right? It's really research. But we do have a couple of the product teams at Redgate that are starting to use this where, as I said, I just downloaded in Spawn, this executable. I kind of authenticate myself. So there's an authentication piece. And then what this really is it's running in Kubernetes, and it creates a container from an image for a data source. So we have, a base SQL Server install, Oracle, Mongo, Postgres, I think Redis too. I forget which ones there are. And what would happen is, just like I might do with my code, where I say, all right, I write hello world. So I have a class and I have a method. And then I go, all right, I'm going to add another class to this and enhance it. And so in the container world, what I would do is build a new container that would have two classes in it. So when I run it, I have two different types of API access. In this case, we do the same thing with database. So I can specify, say, give me an empty Postgres database. In essence, that gives me an image. And then what I start to do is I start to say, all right, how would I source this? Is it blank, or do I restore something from a backup? And then how do I upgrade it over time? How do I version this out and store the different copies of it? So it's there's a lot to it. I would encourage you to read some of this if you're interested. I have no idea if we'll ever sell this as a product right now, but it's more of a vision of what we think that perhaps Redgate, perhaps Azure or AWS or somebody else should be doing to provide a database as a service, and not just provide, a blank SQL Server or a blank Oracle server.
Okay, thanks, Steve. Let me go back here to the comments. And yeah, so there was a question if Spawn works for any database, and you just respond to that question. So yep. Yes.
Yeah. So it's
there is another interesting question here. Giovanni de Leon from Guatemala asks, what do you mean with data virtualization?
So data virtualization kind of becomes giving me an abstraction to my data. So right now, when I query SQL Server and it goes to a data file, there is an MDF and LDF that where my data is stored. In data virtualization, we abstract that away so that potentially there's one copy of my sales table, and multiple developers can access that from different SQL Server instances, or they see it as a read-only version of that database. So maybe the easiest way, and I don't mean to promote this because there are other solutions for how this works.
No.
But obviously, the easiest way for me to talk about is some of the things we do at Redgate. At Redgate, we have SQL Clone, which essentially what it allows us to do is create an image of an MDF file and then share that amongst multiple servers, multiple SQL Server instances. So what we're doing is we're kind of virtualizing the data away from the SQL Server itself. And so we can have multiple copies of this for different developers to see their own view, but I don't have to take a 1 terabyte database and allocate 4 terabytes for 4 developers. I can just have 1 terabyte for 4 developers. So there are a number of versions of how this works, and there's different vendors that have similar solutions. So if you search data virtualization, you'll see different ways of implementing this abstraction layer away from the actual data platform itself.
Okay, well, that's great. We have a very interesting question here regarding Docker databases. So do you think we're ready to use databases on Docker in a production environment?
Let me ask you this, Carlos, do you think we're ready to use databases?
That's not fair. Oh. Well, I would I would say no, Docker not, probably is not. Docker is better for your own environment, for your own development environment or staging. You don't want to, production is delicate. So you want to use something like Kubernetes to port all your development from Docker to Kubernetes, because Kubernetes is a container orchestrator. So it makes sure all your containers are up and running. You define your desired state. So this platform is going to make sure everything goes as expected. So my recommendation is no, at least for now. Docker is not it doesn't comes with high availability out of the box. So it's more like something local or something for a small project.
So
go ahead.
Let's step back, Carlos. So let's ignore Docker for a second, right? Because Docker is just an implementation. So let's say containers, databases and containers. So you would say we could do databases and containers in production, right?
Yeah, because we can isolate our layers. We have our compute layer separate from our storage layer. store data?
I would agree, right? So really, what we're doing with a container is we're virtualizing the OS, just like we would virtualize the machine with a VM and a hypervisor. So Docker or Kubernetes or some runtime that will virtualize the OS is what will run the database. And so essentially, you've said, I'm going to take my hypervisor plus my virtual machine, I'm going to shrink it to a runtime that does a container. And that's a very stable thing. Linux has been running containers in the LXC project for 11, 12, 13 years now. I think you totally can put databases in production environments in containers, but it's like with any technology, you have to understand how it works and you have to have sysadmins that are able to support that. But I think it's stable and I think it works fine.
Yeah, for us as DBAs, it would be a SQL server.
It's just a SQL server, right? When I run SQL server container, the container disappears. I don't care. It's just a SQL server.
Yeah, exactly. All right. So we have a very interesting question. It comes from Alba as well. She is following us from Honduras. So she's asking, this is really, really good. What about security? Can you tell us a little bit more about it in this new line of service or database as service?
Right. So security is obviously a concern, and I think far too often we've built technology without considering security. In the database as a service, if you think about how I do security now for things like GitHub, or how I would do security for when I give access in Rackspace or Azure DevOps or in AWS, right? I have some sort of authentication account and I'm providing access to resources. And so I think the same thing happens here. In Spawn, there's at least the way that we thought about security was from the very beginning that we will have authenticated accounts. So there are people that are authenticated, and we, in general, I don't even know if I wonder if I can show this.
Sure. Let me switch back to your.
Yeah. So if I do a Spawn CTL auth in this case, what actually happens is it asks me if I want to authenticate, and let me just drag this over, with GitHub or with Microsoft. And so in this case, I'm using some sort of OAuth procedure. And if I'm not going to click the GitHub thing here now, but, if I do that, I'll authenticate and I'll get some sort of token that I'll have to type in here to authenticate with the service. Once I authenticate, then there is a hierarchy of my account is associated with certain teams, and those teams have access to certain copies of databases, essentially, is the way it works. And so I think that that's the way that we would actually do this in the future as well. I don't know if there's actually a security thing in here. There's an authenticate. It says there'll be some token that I'll get here and I'll authenticate. But just like with any other web service or any other service that we were to use, whether that's on premises or in the cloud, we would expect that we have to authenticate our identity somehow, some personal token, some sort of name, password, two-factor thing. And then somebody is set up to say that this account has rights to these different databases. And so while I don't think anybody would manage Kubernetes per se in this sense, they would manage how do I get images in there, right, for these containers and who has access to which ones.
Yeah, that makes sense. We have many questions coming up. I don't know if are we okay?
No, I'm fine.
Okay.
As soon as I do this, I have to go work outside.
Yeah, we have so many great questions here. So Eduardo is asking, what are your thoughts on performance tuning? Do you consider that is more critical than ever on cloud platforms? I think, yeah.
Yeah. So I hate to say it depends, but it depends because
yeah, it depends.
We're always balancing performance tuning of the cost of hardware versus the cost of developer time. That's what we're always doing, or the cost of DBA time. And so I think as you move to the cloud, the challenge is that because I'm paying by transaction, by IOP, by everything else, I have to decide that how much do I pay versus how much do I try to reduce those things with better code. And so we can certainly, if Itzik Ben-Gan or, certain people were to write the code, they would tune that down very, very well. But for many of us, we have to balance that out with how much time do I spend tuning this code versus how much does it cost me? Because there's times where maybe I just need things to work, or I need them to work, or I just need them deployed for customers. So maybe I just buy more compute capacity in a cloud and I deal with it. But then there are times where we go across weeks or months or years. It's very, very expensive to run these cloud platforms. So maybe I should be tuning my code. And so I absolutely think you should learn to write well-performant code and you should deploy it. Most of us should improve our T-SQL skills all the time so that as we deploy code, it's fairly efficient from the very beginning. But in terms of performance, then you just have to decide, is it worth it for somebody to spend time on this because I pay them versus what I pay the cloud vendor? And that's, I think that's a very difficult question to answer as you're in a development team. Most of the time, I think you do want to write better code where you can, but there's definitely a point where it becomes less efficient to continue tuning something, and you might want to just pay more money for it to run, because if I'm tuning that code, then I'm not doing other work. So it's a balancing thing that you have to do.
Yeah. Of course, there is a very interesting question here. There is a question from Herbert, but I think it was addressed before about continuous on production. So we briefly talk about it. And this is another question from Albot from Facebook. So this is great. She says, how do you think we as current tech professionals working with databases should prepare for what is coming? What would you suggest we need to get better on to be prepared for the, I think it
future,
was
I guess, probably, right.
Yeah, the future, probably, yeah.
Yeah, I think that, I mean, first of all, most of us have some job that we do, right? I'm a software developer, I'm a Python developer, I'm a T-SQL developer or something. You should try to be improving your skills in that area, because all of us can be better at many of those things. And so improving in your primary area is a big deal. I think as we look for the future, understanding what happens with a container, I think, is important, because I do think that this is a technology like virtual machines will be adopted quite heavily. And so you will want to run containers on your local machine, whether that's with Docker or some other implementation. You're going to want to do that. Unlike Nigel, I don't really recommend Kubernetes, because I think most of us will never run Kubernetes. We'll just say, I need a database to run, and somebody else figure out how that works. But I do think that improving your skills in your primary area, whether that's SSIS or SQL Server or C#, do that, and then understand containers, because I do think that containers will change how we work with things over time. Because a container running on my laptop is really the same as a container running in AWS, but I do need to understand how to address it and get to it and start it and all those kinds of things.
Yep, I think we'll forget about it work in my computer. Yeah. Remember that it was working fine. We'll forget about that.
We will, because if it works in my container, it'll work in another container, another container service.
Yeah, we have another great question here from Eric Contreras. He says, how does the sharing images benefit the developers in a case where both of the developers from the team make changes at the same time? How do they merge the changes without losing one of the images? Okay.
So, I mean, there's two sides to this, right? So there's a code side of this. So if I change a table and Carlos changes a table, how do we merge that code together, right? Or we both change the store procedure. And then there's a data side as well. So on the code side, we deal with this problem all the time right now. Merging code is one of the most difficult things to do in the world.
It is.
Which is why we want to merge code often, right? We don't want to let me work for a week and Carlos work for a week and then try to merge our changes together if we're at all working in the same area, because that merge process will eat up a lot of time as we debate and argue and try to figure out what each of us wanted to do. So we do, in this DevOps world, try to merge changes in code very quickly so that I don't make too many changes that might conflict with somebody else. Mm-hmm. And the way that we do this with databases is the same way we do it with other code. We'll get two store procedures or two table definition statements, and we have to decide how to merge that stuff together. There isn't a lot of maturity in T-SQL. Let's leave out T-SQL, SQL merging of code, because our code tends to be monolithic in some way, right? A table statement or a store procedure, and a C# class tends not to be, because I have properties and methods that are inherently separate. So Carlos and I can work on the same Python class, and not necessarily touch the same code for each other, and it would merge fine. Whereas if we touch the same table statement or we touch the same stored procedure, that's not the case at all. Right? So that's a challenge. In terms of the data element, when we have these different images, each developer sees a different copy of it. So their changes are separate. And merging those in terms of data would be the same type of thing where we have to decide what changes make sense. So if I'm merging a list of countries and Carlos is working on a list of countries and we change the name of a country, right? Because country names change, we would have to, again, have some method that would say, there's a primary key here. They both change the same data. We're going to try to put that back into an image that we'll use for the next round of development. Which one is correct? And so really, the human element comes into play whenever we do code merges. There are some tooling that will do merges for code, but it's hit and miss. It's really hit and miss because computers don't necessarily understand the logic of why we're trying to do something in code. Same thing for data. Right. And so allowing automatic merges would be challenging.
It is. Yeah. And there's tools like Flyway, right? You're speaking directly for schema changes and, getting control of the version of your database.
Those do work, right? But they don't help with conflicts, right? So if you and I change the same table, they don't necessarily help there.
With the merge, yeah. They're getting there. Right. They're getting there. I know there are some certain validations you can do, so they are getting better and better.
They are. Most of our validations just raise a flag and go, would you please go look at this?
Yep. All right, moving on to the next question. We have a question from Billy Racket. He asked, what are the advantages and disadvantages of databases as a service?
So, Billy, thanks. That's it's a tough question in that we don't have a lot of database as a service for us to really look at and say, how will this work? From our research, when we think about, the advantages are that we get a standardized platform for developers to work on. So if I'm working on a project, if we're building a new Tech Community Day site, we have a standard database that we can deploy for Carlos, for myself, for others to look at and use in their development. And so we don't end up with more edge cases or more potential bugs flowing through because I have a different data set or I have a different configuration of my database than somebody else does. So that's one of the big advantages there. The other thing is that as we've looked at this over time, and part of the reason containers excite many people is that the infrastructure level to manage a SQL Server is fairly high. If you just think about today, if you install SQL Server today, and then you go, I want to use it for an application, what are all the things you have to do to get that running, right? I have to set up a security account. I have to create a database. I have to create a schema. I have to start. There's a lot of work to manage that. And that's not to mention that every other month I'm going to get a patch from Microsoft to do this. So one of the advantages of taking away all of that infrastructure work and one person does it or one small part of their job is doing it because they do it once for the container image and then that's deployed everywhere else. So rather than me patching a laptop and Carlos patching a laptop, we get an image that's patched, right? And somebody patches it in part of the process. Now, the disadvantages are that obviously anytime you have a service, it's somebody else's computer, somebody else's. Yeah. So you have to trust that the vendor does a good job. You have to have network connectivity. Even inside your own data center, I have to trust that my admins are running the service correctly. There's the weighing of the cost of building an infrastructure and managing that somehow. Right? For us, we actually have Spawn running on Kubernetes, and most of the time, actually, we figured it out. So it's one developer that's part-time can manage that Kubernetes thing, but every once in a while it fails. And so then I lose a developer day of work because he's trying to play with Kubernetes to make it work. So, the disadvantage is I'm just kind of moving that work to somebody else and I'm paying for it in a different way. And so if that's a labor cost or that's just a billing cost to some company, that's something I have to consider in line of doing it some other way. The cloud, I think, is fantastic for things where I have to burst and scale and change capacity. But if I had a steady workload that I knew, the cloud, I think, sometimes is very expensive for that. It's not as efficient as doing it on premise.
Okay, we have more greetings here from Antigua, Guatemala. Yeah,
Thank you.
it's a beautiful place. You should check. Maybe
Yeah, I
next
want to
time
go
that we will,
sometime.
yeah, we'll get there some next time,
One of
maybe
these,
2021. Tech community.
hopefully. Hopefully.
Yeah, hopefully. All right. And we have one question left, I think. Yeah, we have a really good question here from Herbert. He's asking, do you recommend to create your own database containers versus using the official images? In which cases it could be valid to build your own?
Your Honor, this is probably a better question for Carlos, but I think you always want to start with the official. Like if you're, let's just use SQL Server as an example, or Redis, right? You always want to start with that official image because the installation of that software and stuff as part of a Docker build, it's not terribly hard, but it's silly for you to do it. There's no advantage for you to do that, right? But what you would do is you would take the SQL Server 2019 image, you would create a database in there, you would add your schema, and then what you would do is save that back as a new image, right? Whether that's manual or Docker build or whatever. And all your future changes would be built on your image, not on the base image. So I'd only go back to the base image when I needed a new database, a new project, something else. Otherwise, I would always be working off my image. So I would say SQL Server 2019, then I would upgrade, to my software. Now, as they patch that image, you may kind of redo that process again. So if I've created a database and added a table, and then I add a second table, right? So I have a second image. Then Microsoft patches with CU1. So what I probably then do is take that database with the two tables and add it to the CU1 image, and then that becomes my basis for all further work until they patch that image again. Because I do think, and Carlos, let me know what you think, trying to patch those images is slightly silly. I think you would go back to the base patched image, right?
That's right. And with the ability of having your data in a different volume, it doesn't matter to change the base container that has the binaries. So you will be moving around just the base image that is the version with the binaries, and that's it. And as you describe it perfectly, you can rely on the official image that has certain version. That you can add many layers to that image, putting your backups or restoring your databases or pulling stuff from GitHub or stuff like that, crazy stuff like that I was doing.
Yeah, there's a lot to do. Do you think, like, if you are going to volume your stuff off, you got to make sure master and other system databases are volumed off as well, because you'll have security and you'll have different things there. So not just your database volumed off, but all the data, for instance.
Yep. And we have one last question from Renato Cabrera. He asks, suppose I have a database with my app. If I make a database container-based deployment, how will the data persist?
Great question, Renata. You use volumes. You have persistent volumes. In Docker, you would map a volume, or container, you would map a volume to a local store on a disk or LUN somewhere. In Kubernetes, you would actually create a volume object and map your data store there so that it does persist, because containers are not necessarily built to persist for time.
Exactly.
Yeah.
Ephemeral. Yeah. Volumes is the way to go for data persistency for databases. Yeah. No way around. So I think that was the last question we have. Wow, that was a great time.
Many great questions. Thank you for having me.
No, thank you so much for take the time to give us this amazing keynote. We have so many great thoughts, stuff that we have to consider for the future, more for in applies for anybody, right? A DBA, a database developer, and an application developer, and everything is changing. So we have to adapt and continue learning this new stuff that is coming up. And I appreciate your time, and I appreciate everybody that is stick with us in this streaming. And there will be more sessions coming today. I think we have a variety of topics. There will be DevOps, data platform, stuff like that. Most of these sessions are from the Guatemala community leaders, so it will be interesting.
No, tune into something else. There are some great sessions coming.
All right. So that's all for this keynote. Thank you very much for you guys for sticking here with us. And thank you, Steve, once again. And have a wonderful weekend.
Yes, thank you. Thank you, everybody. Enjoy
Yes.
your day.
Thank you.
Bye.
Bye. Let me go. All right.